Okay, so this is GCSE Papers Shadow Set 1, Higher Tier, Paper 1, Tuesday 21st of May 2019. This is a walkthrough of the entire paper with all the worked solutions and some brief explanations. So, question 1, probability. So there's blue, red and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The 0.4 is there. It says the number of red cubes in the box is the same as the number of yellow cubes in the box. Complete the table. Right, we know that this has to add up to 1. So 1 take away the 0.4 leaves 0.6, and 0.6 is spread between these two, split between these two, 0.3 for each of those. Part B. It says there's 24 blue cubes in the box. Work out the total number of cubes in the box. Well, if you see there, I've put the percentages on, just one way to think about it. So 40% of the cubes are blue because the probability was 0.4. 0.4 and 40% are equivalent. So 40% of the cubes are blue. So that means that 40% is worth 24 cubes. And you need to work out what 100% is, because that would be all of them. So I've divided by 4 to find out what 10% is. So 10% is worth 6 cubes. And then multiplied by 10 to find out what 100% is, all of them. So that is 60 cubes, which means there must be 60 cubes in total. Okay, moving on. Question 2. Question 2, it says Michelle needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar, and she needs 2 times as much butter as sugar, and she's going to make 75 biscuits. So remember, this is the amount you need for 15 biscuits. So I've said here, for 15 biscuits, Michelle needs 50 grams of sugar. For 15 biscuits, Michelle needs 50 grams times 3 times as much flour. It means you would need 150 grams of flour. Okay, because that was for 15 biscuits, we need to multiply by 5, right? Because how many 15s go into 75 5 times? So for 75 biscuits, Michelle needs 150 grams times 5, 750 grams of flour. Okay, part B uses a similar technique, but in a slightly different way. So for 15 biscuits, she needs 50 times 2, because we're talking about sugar this time, and sugar is 2 times as much butter as sugar. So in fact that should have said butter. So for 15 biscuits, Michelle needs 100 grams of butter. For 75 biscuits, you need to multiply it by 5 again for the same reason as above. So it means that she needs 500 grams of butter. So therefore Michelle will need 3 packets of butter and we'll have 100 left over, because butter comes in 200 gram packets. So 2 packets would be 400 grams, 3 packets would be 600 grams. So she'll have 100 grams left over. She needs 3 packets. Question 3. Question 3 is a highest common factor question. There's a few different ways to go about doing this. I've chosen the prime factor tree. So I've done prime factor trees for 84, prime factor trees for 144, and I've got 2, 3, 2 and 7 on the end of my trees. The prime factors of 84, 2, 2, 3 and 7. Prime factors of 144 are 3, 2, 2, 3, 2 and 2. Put them into a Venn diagram. So the ones in the middle are the ones that are in both. So for example, there's a 2 there and a 2 there, which means we put a 2 in the middle. There's a 3 there and a 3 there, which means we put a 3 in the middle, and another 2 there and another 2 there, which means another 2 in the middle. And there's nothing else that's in both of them. Okay, so the 7 goes on its own, and the rest of the ones that we haven't already crossed off would go on their own there. And the highest common factor are the ones in the intersection multiplied together. So 2 times 3 times 2. Highest common factor is 12. Number 4. So the diagram shows the plan, which is like the bird's eye view, the plan view, the front elevation and the side elevation. So the view from the front and the view from the side of this solid shape. And it's drawn on a accurate centimetre grid. And your task was to draw a sketch of what that shape is. So that's what it looks like from above. That's what it looks like from the front. that's what it looks like from the side. And what you would get is a cylinder. Okay, so you'd see a circle from if you're looking directly above, and you would actually see a rectangle if you look directly from this side, and then a rectangle if you look directly from that side. Okay, what is important is that you give the dimensions. So it should be 5 centimeters up, because there is 1, 2, 3, 4, 5 centimeters up here, and the diameter would be 4 centimeters, because there's 1, 2, 3, 4 going across here, and also 1, 2, 3, 4 going across there. So cylinder with these dimensions for those 2 marks. Question 5. Question 5, so we've got shapes on a grid, and we know that shape A can be transformed to shape B by a reflection in the x-axis followed by a translation of something. So first thing I've done for the first mark is drawn the reflection in the x-axis. That's where it would go there. So when A is reflected in the x-axis, it would become here, and then we need to get from here to shape B using a translation. And you can see if I pick that point to start on, it means I need to end on this point, the equivalent point, and it is 7 to the left, 1, 2, 3, 4, 5, 6, 7, and then 1 down, 1 down, 7 left, 1 down. That would 7 left and 1 down. There's the translation, and so C is -7 and D is -1. Get that initial bit, get that an intermediate part drawn for the first mark. Done. Next question, ratio problem solving question. So a shop sells packs of black pens, red pens and green pens. There are 4 pens in each pack of black pens, 5 pens in each pack of red pens, and 6 pens in each pack of green pens. On Monday, the number of packs of black pens to the number of packs of red pens to the number of packs of green pens is 7 to 3 to 4, and there are a total of 268 pens sold. So we know that packs of black pens, packs of red pens, packs of green pens, 7 to 3 to 4. We're told in the question up here that there are 4 pens in each pack of black pens. So if it was 7 times 4 in each pack, 7 times 4 is 28. Equivalently, with red, because there's 5 red and then 6 green, we need to do 3 times 5 and we need to do 4 times 6. So then we get this ratio, 28 to 15 to 24. That ratio tells us the number of what the ratio of the number of pens is, okay, which is different to the number of packs. So now we need to divide the number of pens sold in total in this ratio, 28 to 15 to 24. So this lot, 28, 15, 24 adds up to 67. So we do 268 divided by 67, which is 4, and then 15 times 4, because we're looking at the red pens, and the answer is 60. Question 7. We've got 2 rectangles, A, B, C, D, and P, Q, R, S. We're told in the question that QR is 20, so that's why I've written that on there. We're also told in the question that BC equals PQ. So we know that this length is exactly the same as this length, okay? We're told that the perimeter of ABCD is 52, and we're told the area of PQRS is 90, which is why I put the 90 on there. Now this bit is how we're going to get our first bit of information, how we're going to work out our first length, because if we know the area and we know this length, then we can work out this length. We can work out PQ by doing 90 divided by 20, and that'll tell us what PQ is. Okay, so that's the first thing I've done. 90 divided by 20 is 4.5. You might wish to think of that as 90 over 20, which simplifies to 9 over 2, which is 4.5. Remember, this is a non-calculator paper. So we know that the length PQ is 4.5, and if we know that PQ is 4.5, then BC is also 4.5, because it tells us it in the question. So I've redrawn ABCD, I've put my 4.5 centimetres on BC, and now we need to just work out this length here. Okay, so if BC is 4.5, then obviously as it's a rectangle, the opposite side will also be, opposite length will also be 4.5 centimetres. And we're told the perimeter of this shape is 52. So this plus this plus this plus this is 52. So I've just done 52, take away the 4.5, take away the opposite 4.5, left with 43, and then half the 43 to work out what each of these two lengths here are. And that's what we wanted. We wanted AB, 43 divided by 2 is 21.5 centimetres. 21.5 centimetres. Okay, question number 8. Question number 8, estimate the value of this. So if we're estimating, and we're talking about square roots, you want to look at that. You know, we're not necessarily automatically going to round everything to one significant figure, because although I could do a square root of 100, I can't do a square root of 60 without a calculator. However, I can see that's very close to a square number. It's close to 64, and that we know we can do a square root of. So those are the numbers that I have rounded them to, 64 and 100. So if I do the square root of 64 times 100, which is the square root of 6,400, it is 80. Okay, so the answer is 80. You get 1 mark for choosing the correct values to round to, second mark for actually getting 80. Part B and C, we know that 2.4 to the power 6 is 191, correct 3 significant figures. We need to work out the value of 0.24 to the power 6, correct to 3 significant figures, and the answer would be 0.000191 for 1 mark. And then we're on to part C. We've got to find the value of 4 to the power minus 2. If you've got a negative power, it just makes it 1 over. So it becomes 1 over 4 to the power of 2. And 4 squared is 16, so it just becomes 1 over 16. And moving on to question number 9. Question number 9, fractions multiplication. So to multiply fractions, you're going to need to make them, remove them from mixed numbers and change them to improper fractions or top-heavy fractions. So 4.5 is 9 over 2. 1 4/5 is 9 over 5. There's no diagonal cancelling or anything going on here, so 9 times 9 is 81, 2 times 5 is 10, 81 over 10. You need to give your answer as a mixed number, and 81 over 10 is 8 1/10. 8 1/10. Question number 10. Question number 10. So we've got graphs with those equations 16y plus 27x equals 193 over 2. And 15y take 19x is 24, drawn on the graph, the two straight lines. It says, use the graphs to find estimates of the solutions to these simultaneous equations. Well, to solve simultaneous equations graphically, all you are looking for are the points of intersection of the graph. So the two straight lines intersect at this point here. So this is where these two simultaneous equations can be solved. So you just need to work out the x value, which is why I've put this dotted line on, and the y value, which is why I've put this dotted line on. So the x value is simply 1.5, and the y value is 3.5. 1.5 and 3.5. Question 11. Bus company recorded the ages in years of people on coach A and the people on coach B. There's the 23 people on coach A, and you need to complete the table. We need to find the median, the lower quartile and the upper quartile. First one I found was the median, 58, that's the one in the middle. The way they've written this out makes it really easy to see that one's in the middle, because we've clearly got that number before it and these ones after it. So that one's definitely in the middle. Okay. So I put a circle around that one, and then we need the lower quartile and the upper quartile. So the lower quartile is just halfway between the start and the median, and the upper quartile is halfway between the median and the end. Okay, so 53 is the lower quartile, and again you can see it visually because there's 1, 2, 3, 4, 5 on this side, and 1, 2, 3, 4, 5 on this side in the middle. Okay, and the same thing here. So if we're going from the median to what is the upper quartile. 1, 2, 3, 4, 5 before it, 1, 2, 3, 4, 5 after. It's bang in the middle. So those are our values: median, lower quartile and upper quartile. And then the next part says that, so we've got info for coach A, info for coach B. Percival says that people on coach A are younger than people on coach B. Is Percival correct? Well, on average, people on coach A are definitely younger, because on average, people on coach A are age 58, people on coach B are age 70. So definitely they're younger here, right? Another key bit of information is the fact that all of the values are lower in table A. Okay, the average person is younger, the youngest person is younger, the oldest person is still younger on coach A. Okay, the quartiles are all lower, so every bit of information is lower for coach A. So yes, Percival is correct. So yes, Percival is correct. And the part C says, Percival says that people on coach A vary more in age than people on coach B. Is he correct? This time I think Percival is incorrect. The range is greater on coach B because the oldest take the youngest is 43, whereas on coach A the oldest take the youngest is only 40. Okay, so coach A has a smaller range, which means it varies less. And also looking at the interquartile range, for coach B, the upper quartile take away the lower quartile is 19, and for coach A the interquartile range, upper quartile take away lower quartile is 14. Again, the interquartile range is less, which means it is less spread out. So Percival was incorrect. Moving on to question 12, the three spheres. So the volume of sphere Q is 150% more than the volume of sphere P. The volume of sphere R is 50% more than the volume of sphere Q. So I've chosen to do this as a ratio. There will be other ways that you can do this question. I've chosen as a ratio, and I've just picked an easy number to start with. So if I imagine the volume of sphere P is 100, then the volume of sphere Q would be 250. Okay, so 150% more. Not 50% more, 150% more. Okay, so I've just chose those numbers. I've chosen a number to start off with that will make things easy. Okay, so 150% more, P and Q, 100 to 250. It then says the volume of sphere R is 50% more than the volume of sphere Q. Well, if we're now taking the volume of sphere Q to be 250, so that it stays in relation to P, okay, then 50% more than 250 would be adding on another 125, adding on 50%. So therefore R would be 375. Okay, so now all of those are in relation to each other. Okay, which is why we can now express the volume of sphere P as a fraction of the volume of sphere R, because P is 100 and R is 375, right? So 100 out of 375. Okay, I've simplified it all the way down to 4/15. Okay, but choosing that straightforward, easy number to start with is the key to that question. Okay, I think if you pick any other number other than 100, you are making your life more difficult, because you're going to end up with decimals. Notice there's not a single decimal in sight there, and we don't need it. Pick an easy number to start with. 100 is always going to be the easiest number to deal with. Okay. Question number 13. N is a whole number. Prove that n squared plus n plus 1 all squared is always an odd number. Okay, so it's just a bit of algebra and then knowing a few techniques. So n squared plus n plus 1 squared. So n plus 1 squared is n plus 1 brackets n plus 1. Multiply these double brackets will give us, so this bit gives us this, n squared plus n plus n plus 1. Okay, and then we've got this n squared, so it's n squared plus n squared plus n plus n plus 1, which simplifies to this, 2n squared plus 2n plus 1. I've now factorised these first two terms to take a factor of 2 out. So it's 2 brackets n squared plus n and then plus 1. Now that is always even. 2 lots of anything, 2 times anything is always even. 2 times 3 is even, 2 times 7 is even, 2 times 10 is even, 2 times n is even, 2 times n squared plus n is always even. And therefore, if 2 lots of n squared plus n is always even, then 2 lots of n squared plus n, bracket, plus 1 is always odd. Okay, really common question in an exam doing this type of technique. Okay, and knowing that 2 lots of something is always even, and therefore 2 lots of something plus 1 is always odd. Question 14, you have simply got to learn these exact values of trigonometry. Okay, now there's a few different ways you can do them. You need to find the method that your teacher may use and or learn a method and remember it. So tan 60 is root 3, sine 30 is a half, so it's root 3 times a half, which is just root 3 over 2. Question 15, a lot of to do with volume of shapes. So we've got a cone on top of a hemisphere. A hemisphere is half of a sphere. We're very kindly given the formula to find the volume of a cone and the volume of a sphere. Now remember, you don't want, we're talking about a hemisphere here, half of a sphere. So if this is the volume for a sphere, 4/3 pi r cubed, then the volume of a hemisphere, half of it, would just be 2/3 pi r cubed. Okay, that'll be crucial in the working down below. So we're told the height of a cone is 20, it's on the diagram. The base of the cone has a diameter of 12 and the hemisphere has a diameter of 12. Okay, we're told the total volume of the shape is k times pi centimetre cubed, where k is an integer. Task is to work out what k is. Okay, so just step by step. So the first thing I've done is the volume of the cone, substituted things into the formula that we're given, 1/3 times pi times r squared times h. So in this case, 1/3 times pi times the radius squared times the height. 1/3 times pi times 36 times 20. Now remember, this is a non-calculator paper, so to make this easier, I've just done my 1/3 of 36, which is 12, and I've kept my pi and I've kept my 20. So 1/3 of 36 gave me the 12, and then I've got pi and 20. So now I've got pi times 12 times 20. 12 times 20 is 240, so it's 240 pi. Okay, non-calculator question, so we're keeping it in terms of pi. So the volume of the cone, 240 pi centimetres cubed. Do the exact same sort of thing this time with the hemisphere. So like I said earlier, it's not going to be 4/3 pi times radius cubed, it's going to be 2/3 pi times radius cubed, because we're only talking about a hemisphere, half of a sphere. So 2/3 times pi times 6 cubed, 2/3 times pi times 216, 6 cubed 216, and 2/3 of 216 is 144. So it's 144 pi centimetres cubed. So therefore the total volume are these two things added together, which is 384 pi centimetres cubed, and therefore k is 384. Question 16. Question 16, the one about the lock. So 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4, 5, 6. 3-digit number 553 is one way the dials can be set as shown on the diagram. Work out the number of different 3-digit numbers that can be set for the combination lock. It's just 6 times 6 times 6. That could be 6, that could be any one of 6, that could be any one of 6. Okay, so 6 times 6 times 6, which is 216. Next part says, how many of the possible 3-digit numbers have 3 different digits? Well, this time it's 6 times 5 times 4, because, for example, if I got a 5 on the first one, then I wouldn't be allowed to get a 5 on the next one if the numbers were going to be different. So therefore there's a possible 6 different numbers I can pick on the first one, but there's only 5 numbers I can pick on the second one. So for example, 5 then 4, and therefore I can't pick a 5 or a 4 on this one. So I've only got 4 things to choose from. So 6 things, 5 things, 4 things. 6 different numbers, 5 different numbers, 4 different numbers. 6 times 5 times 4. And without a calculator, I've just done 6 times 5 is 30, 30 times 4 is 120. So it's 120. Question 17. A few different ways that you can approach this one. So we know that x squared to minus 2x plus 12 is equal to 1 to 2. So this is in the ratio 1 to 2. So because they're in the same ratio, we can say that 1 divided by 2 must be equal to x squared divided by minus 2x plus 12. Okay, so x squared divided by minus 2x plus 12 must be equal to 1 divided by 2. Okay, and then you've just got an equation to solve. So I've just done diagonal multiplication, so 2 times x squared and 1 times minus 2x plus 12. Get this. It then needs to be rearranged. It's a quadratic. It's got an x squared, an x, and a number term, a constant term. So rearrange it, set it to equal to 0, because that's how you always solve a quadratic. Set it equal to 0. Make your life a lot easier if you recognise here that all of those numbers are divisible by 2, because divide that by 2, divide that by 2, divide that by 2, divide that by 2, I then get a much, much, much easier quadratic to factorise. Factorises to x plus 3x take 2, and therefore the solutions are x equals minus 3 or x equals 2. You might well have noticed there's another method over here which is not really any different. It's just a different way to think about starting it that in my experience I've noticed some people prefer. So we know that this is in the ratio 1 to 2, which is kind of saying this number here is double this number here. So therefore this expression here is double this expression here, which is all I've done down here. This expression here needs to be the x squared times 2. This expression here is this one times 2. Yeah, this one, 2, is this one times 2. Okay, and you end up with the exact same thing. If you notice there is exactly the same as there. Okay, and then just work it through the exact same way, and of course you get the exact same 2 solutions, which is the possible values of x that you're asked to find at the start. Minus 3, positive 2. Moving on to question 18, a surds question. So we've got root 2 plus root 18, need to put it in the form a root 2. So I need to look for a square number that goes into 18. Of course it's 9, so this becomes root 2 plus 9 root 2. Root 2 plus root 9 root 2, and the square root of 9 is 3, so it becomes root 2 plus 3 root 2, which is of course 4 root 2. Yeah, 1 root 2 plus 3 root 2 is 4 root 2. Just like 1x plus 3x is 4x. Done. This one requires a bit more thinking. So we've got 1 over root 2 to the power 9, and we need to put it in this form with a rational denominator. So we've got this going on. That's a 16 there, not a 66. So we've got 1 to the power 9, which is obviously 1, and we've got root 2 to the power 9. Now I think the easiest way to explain this is to think that this is root 2 times root 2 times root 2 times root 2 times root 2 9 times. Okay, so root 2 times 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 root 2. There's 8 of them. That's the same as just doing 2 times 2 times 2 times 2. Root 2 times 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 root 2 is the same as just doing 2 times 2 times 2 times 2, which of course is 16. And then we've still got 1 more root 2, so we've to add on, so we end up with 16 times root 2, which is this. Okay, so we end up with 1 over 16 root 2. And then, because we've got a irrational denominator, we've got a surd on the denominator, we need to rationalise the denominator. So to rationalise this denominator, we're going to multiply numerator and denominator by root 2. Okay, so it keeps the value of the expression the same. So 1 times root 2 is root 2, and 16 root 2 times root 2 is just the same as 16 times 2, which is 32. So the answer is root 2 over 32. Moving on to number 19, completing the square. So you're told that x squared take 8x plus 1 needs to be rewritten in this form: x take a all squared, take away b. Find the value of a and b. It's a completing the square question. Okay, if we can learn to complete the square, half this number gives us the 4, and then 4 squared is 16. How are we getting from 16 to 1? We're going to take away 15. So we've completed the square, and our answers are a is 4. Not minus 4, it's 4, because it says take away a, and so it's take away 4. And b is 15, because it says take away b, and we've already got the minus sign, so take away 15. B is 15. And then write down the coordinates of the turning point. So we've got this graph. We want to find where this is a minimum, and it's a minimum when x is 4, because when x is 4, we get 4 take 4, which is nothing, so that completely disappears, and we're just left with minus 15. Okay, so y is minus 15, so the x coordinate is 4, and the y coordinate is minus 15, and that would be the minimum point of that graph. So if we were to plot it, and it would be a quadratic, the minimum point, that point there, would be at the coordinate 4 minus 15, the minimum point, the turning point. We know it's a minimum point because it's a positive x squared graph, so it would be this shape. It would be a U shape. Okay, moving on to number 20, proportion. So we know that h is inversely proportional to p, and we know that p is directly proportional to the square root of t. We know that h is 10 and t is 196 when p is 7. Find a formula for h in terms of t. Okay, so we're going to work out a formula to link h to p, and we're going to work out a formula to link p to t, and then we're going to combine them to get a formula that links h to t. Okay, so this part here is the first part. So h is inversely proportional to p, so therefore h equals k over p. Substitute in the values that we're given. We're given for that h is 10 when p is 7. So 10 equals k over 7. Multiply both sides by 7 to find that k is 70, and then we get this is our formula that links h to p. H equals 70 over p. Okay, now we need to find our formula that links p to t. Well, we know it's we find the formula for p to t, so we know that it's directly proportional, so it's multiplied. So this time I'm going to do p equals k times t, times the square root of t. We know that when p is 7, t is 196, so we know that 7 equals k times square root 196. Root 196 is 14, so we know that k is 7 is k times 14. If we divide both sides by 14, we know that k is equal to a half, so k equals 7 over 14, and 7 over 14 is a half. That's how I've got from there to there. And so if k is a half, we can put it back in here, so we know that p is equal to a half of the square root of t, and that is my formula that links p to t. So now all we now need is a formula that links h to t, and that is here. So h equals 70 over p, but of course p is half of the square root of t, so I'm going to put h equals 70 over half of the square root of t. Okay, so that's the formula that links h to t. I've tidied it up here by simply just multiplying the numerator and denominator by 2, so it keeps it the same value, so that will go to 140, and that, if I multiply it by 2, gets rid of this half fraction, so it just becomes like 1 root t. So this one is a neater, tidier version of the answer, and this is the one I would like you to be able to give. Okay, moving on to question 21, a functions question. Question 21. So we're told we've got functions f and g. So f of x is 3x take 2. G of x is x squared add 2. We need to find f minus 1 of x. So remember, this means the inverse. This means the inverse function. Inverse function. That's what we're looking for. That's what that expression means. Okay? So to find an inverse function, the best way is just simply to set that function, the original function, equal to y, and change the subject of the formula so that you get x being the subject. Okay, so add 2 to both sides, divide both sides by 3, and we end up with y plus 2 all over 3 equals x. And then that's our inverse function, except we just need to replace that y with x. So we get x plus 2 over 3. That's our inverse function. Inverse functions are high-level maths, as you can tell. We're at right at the back end of this GCSE paper. One of the new things that came in when they changed the GCSE as well. But this, if you learn that this just means find the inverse function, and the inverse function is just changing the subject of the formula and then just switching the letter around at the very end, it is not a difficult thing to do. Considering, like I said, we're second last question, that's quite a nice question. That's quite a nice 2 marks to get. Okay. Moving on to part B. Part B says that given that f of g of x equals 2g of f of x, show that 15x squared take 24x plus 8 equals 0. Okay, right, f of g of x means get the function g. So if I just, so we can see the two functions again, there we go. So get the function g and put it into f. Okay, so we're doing f of g of x. So we're going to get the function g, so this, and we're going to put it in f in place of x. So we've got 3 lots of x take 2. We're going to do 3 lots of the g function take away 2. So 3 lots of the g function take away 2. And then just basic algebra, multiply the bracket, tidy it up. Okay? Equivalent thing here, but it's the other way around. We're going to get the f function and put it into g. So we're going to get the f function and put it into g. Okay, so it's going to be, it's x squared plus 2. So it's going to be the f function squared plus 2. So it will be 3x take 2, all squared, and then add 2. So 3x take 2, all squared, and then add 2. And then again, fairly straightforward algebra to multiply out this double bracket and then add 2 on the end. So multiply out the double bracket, add 2 on the end, and tidy it up. 9x squared take 12x plus 6. Okay, now that's fg of x here. This one's gf of x, but of course the question is talking about 2gf of x. So if there's gf of x, then 2gf of x is just multiplying it by 2. Okay, so pretty straightforward. Times it all by 2, we get 18x squared take 24x, add 12. Now it tells us that this is what's going on, that fg of x is equal to 2gf of x. So get my expression for fg of x, which is here. Get my expression for 2gf of x, which is here. Set them equal to each other. And then put it in this form, as in set it equal to 0. And it does. If you rearrange it, it will equal 15x squared. Take 24x plus 8. Now, if your algebra is strong, that is 7 significant marks at the very end of a paper. You know, and we're, you know, this is getting into the verge of grade 9 now. Okay, and this is 7 marks. That's nearly 10% of the whole paper. If your algebra skills are strong, there's no reason why this becomes too much of a challenge, right? Especially this. First 2 marks, they're not too hard. This one, learn the techniques, and there's another 5 marks there for the taking. Right, the final question, probability question. So we're talking about grade 9 probability here. So it's not going to be easy, but step by step it's definitely achievable. So we got, there are only R red counters and B blue counters in a bag. Counter is taken at random from the bag. The probability that the counter is blue is 4/9. The counter is then put back in the bag. 6 more red are added, 3 more blue are added, and then the counter is taken again. And after this second stage, the probability that the counter is blue is 5/12. Find the number of red counters and blue counters that were in that bag originally. Okay, so initially the probability of taking a blue is the number of blue counters out of the number of blue plus red counters. Okay, because there was B blue and there was R red, so in total there's B plus R. The probability of blue, B out of B plus R. Okay, now we're told that the probability of taking a blue at this stage is 4/9, so therefore this is true. B out of B plus R is 4/9. Okay, then after they add some more in, okay, this happens. So we're told now that the probability of blue is 5/12, right? Except this time they've added 6 more red and 3 more blue. So how many blue are in there? B plus 3. And how many are there in total? Well, there's B plus 3 blues and R plus 6 reds. So in total it's B plus 3 plus R plus 6. Okay, and that tidies up to this, B plus 3 out of B plus R plus 9. 3 and 6 is 9. Okay, so therefore we know that B plus 3 over B plus R plus 9 is 5/12. Okay, so the next thing that I've done is just rewritten these two equations, okay, but without the fractions. So you can see all I've done here is just some diagonal multiplication. I've done 9 times B, which must be equal to 4 times B plus R. Okay, 9 times B equals 4 times B plus R, which then multiplies this bracket out to give 4B plus 4R. And then I've just tidied it up so that we've just got 5B minus 4R equals 0. Okay, 5B minus 4R equals 0, because I've got B there and B there, might as well put them together. 5B minus 4R equals 0. Okay, and then I've done exactly the same thing with this one, the diagonal multiplication. So we can see that we get 12 lots of B plus 3, 12 lots of B plus 3 must be equal to 5 lots of B plus R plus 9. 5 times B plus R plus 9. And then exactly the same, just tidied it up. Okay, multiplied out both sets of brackets and then set it so I've got my B's, my R's, and then the constant term, the number term on this side. Okay, this time there was no constant term or number, so that's why we had 0, and this time we got 9. And now if I've got this, 5B minus 4R equals 0, 7B minus 5R equals 9, that should be beginning to ring a bell here. Simultaneous equations. Okay, so just going down this part of the page first, we've got 5B minus 4R equals 0, 7B minus 5R equals 9, and we're just going to solve this set of simultaneous equations. So I've chosen to make these numbers here the same. Okay, so times this one by 5 and this one by 4 gives us this set of simultaneous equations. 25B minus 20R equals 0, 28B minus 20R equals 36, and then same sign, so subtract. So the rule that I always go with is if we've made these ones in the middle the same, then and they've got the same sign, so always make these ones in the middle the same, and then if it's same sign subtract, different signs add, but same sign subtract. Now I've chosen to do this equation subtract this equation because I'm going to not have any negative numbers. 28B take 25B is 3B. Same sign subtract, they will disappear. 36 take away 0 is 36. 3B is 36, therefore B is 12. 3B is 36, so B is 12. And then once we've got one of them, it's pretty straightforward to get the other. If B is 12 and we know that 5B minus 4R is 0, Yeah, one of our original equations. So if b is 12, then we've got 5b must be 60. So we've got 60 minus 4r is 0. Add 4r to both sides. 60 is 4r. Divide by 4, r is 15. And there are our two solutions. The number of red counters is 15, and the number of blue counters is 12. Okay, and that's the end of that paper.